Hey, what's up, guys? This is Chung here. So this time, 1745, palindrome partition number 4. Um, this is a very straightforward problem. So basically, you're given like a string S, and your task is just to check if this current string can be partitioned, can be split into three non-empty palindromic substrings. Otherwise, return false. Right? So I think everyone knows what is the palindrome string is, right? So for example, the first one, right, we have A, B, C, D, B, we have A, B, C, B, D, D. So it returns true because we have A is a palindrome, and then B, C, B is also palindrome, D and D is also palindrome, and the last one is false, right? Because then the second one is false because there's no way we can split the string into three parts, and the constraint is like this. So the length is 2000, so which means that we can easily solve this problem with a n square time complexity, right? So to solve this kind of like split, right, split into three parts, a common strategy is we always fix one part and then we'll try to iterate, brute force the rest two parts. So for this problem, the since it has to be a split, right? So which means that we can simply just try to uh, fix the first string, the first split. Uh, Basically, we try each of the strings, right? We try this one, we try this one, we try this one, we try this one until we have tried everything until this place because we need at least uh, two remaining letters, right, for the second and third substring. And for each of this first string here, right, we just need to check if the first part is a palindrome or not. If it's not a palindrome, we simply just skip that. We continue doing that. And if this current one, for example, if this one is a palindrome, right, and then we just enumerate the remaining parts, we just brute force the remaining parts. We try to split these remaining parts into two parts, right? Similar like the first one, we fix this one as the second one, and then this one, and then third one, right? So on and so forth until we have reached the this one. So, and this is going to be a O of n square time complexity to loop through all the combinations. So which means that we need to check if a substring is a palindrome in O1 time. So which means that we need to pre-process uh, all the substrings to check beforehand to check if each substring is a palindrome or not, right? And to do that, I think it's a very classic palindrome DP problem, right? So we just do this, and we have a length of s, and then we have DP. So the DP we store the flag, right, for each of the substring, and then we have a length of n for this one in range n. So to enumerate all the substrings, there are two ways. The first one is that the outer loop is the length of the substring, and then we have a range of L dot n plus one, right? That's the total length, and the inner loop is the starting point of the substring in range of we have n minus L plus one. That's how we uh, set the range for the starting point, and the ending point, which is j, will be the I plus L minus one. So I mean, you can draw a few examples, and then it should be pretty easy to get this formula here. And then for the dpij, right? So the dpij stores it means that from I to J, the substring from I to J, if that string is a palindrome or not. So this value is going to be what? So first we check if the Si is equal to the Sj. Actually, no, I'll write this one first. So first we need the prerequisite for the dpij to be a true has to be that I and j, Si and Sj has to be the same, right? If this one is true, right, and then we just need to check if the dpi and j will be what? Will equals to if the j minus I is smaller than 2, or the dpi plus 1 j minus 1 is true. And then if either of these conditions are true, and then the dpi ij is true. Right, so this one is like for the case for the 1 and 2 letter case. So obviously the A is a palindrome, and the AA is also a palindrome. Right, so that's this first condition. And the second one is the let's say if the A and A are the same, and then if this one, if the starting point and ending point are the same, then all we need to know if the remaining part, if this part is a palindrome, and then plus this two A's on each side, it's also going to be a palindrome. That's why we have used these two conditions to populate the DP I and J. I mean, like I said, you can always just simply do a loop on top of the instead of doing the length here, you can just always do another loop, right? So you can do for I in range, you just simply loop through the starting and ending point. So now we're starting from the end, right? And then for j in range of I to n, right? So and then you can simply do this. I mean, either of these two works. It's just your own preference. Uh, I sometimes I prefer this one, sometimes I prefer the second one. Doesn't really matter. I think they all works. So now since we have the DPs, we just need to loop through the first part, right? We stop at n minus 2 because we need at least two letters for the second and third substring. Basically, if the DP 0 to I, right? Because the first string is always starting from 0, and if the first part is a palindrome, then we loop through the second and third parts. So uh, for j in range, we start from I plus 1, and then we stop at n minus 1 because this is the second one, right? And then if the second one and the third one are both palindrome, right? I plus 1 to j, right? And dp j plus 1 until the last one is n minus 1. If they're both palindrome, then we simply return true. Otherwise, just return false. Yeah, I think that's it. So run the code. Oh, this is a 1. Yeah, okay. Yeah, so passed, right? So for the time complexity, right, so this so just n square, right? Because we have two nested for loops. Yeah, this one here. Mm, yeah, I think that's it, right? I mean, it's just like a little bit of variation of the palindrome on top of DP here. I mean, as long as you can realize that, you just need to pre-process the DP for each of the substrings, and then the rest is just like brute force, right? All the possibilities of the all those three substrings, and then you can just easily get the answer along the way. Cool. I think I'll just stop here for this problem, and thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.